In this lesson we're going to compare compounds with mixtures, and to do so we're going to take an example of each. On the left we have a mixture called salt water, and that is commonly known as brine or brine water. And on the right we've got a compound called copper 2 oxide. It's a black powder that looks like soot. Now the first thing we're going to compare is how these two materials are made. First of all, the mixture is made by a physical process. All we have to do here is to add salt to water. The water is the solvent, the salt is the solute. We add the salt to the water, we stir it around, and after a while we form a solution of salt water or brine. To make a compound requires a chemical process. So, to make this copper 2 oxide, I'm going to heat some copper powder and stir it around as I'm heating it. Now, you can watch this video in the Watch and Learn section under Metals and their Compounds. By heating the copper in the form of powder, it makes it a lot easier for a chemical reaction to take place. And as we heat this copper powder, it will start to react with oxygen in the air around, and a new substance will be formed, which is the copper 2 oxide. So, mixtures are made through a physical process. Compounds have to be made through a chemical process. Let's have a look at the compositions of each of these substances, of each of these materials. First of all, think about the mixture. Well, the composition of the mixture has no fixed proportion. It's variable. So, for example, you could add 1 tablespoon of salt to the water, or you could add 2, 3 or 4 and stir, and the salt will dissolve. This is not so with a compound. When this reaction takes place, oxygen atoms in the surrounding air combine with copper atoms in a fixed and regular way when they form copper 2 oxide. So we can see that in this diagram, which represents the copper 2 oxide, the copper and the oxygen atoms occur in a regular fixed ratio. So whereas the composition of the mixture is variable, the composition of the compound is not. In this case, for every atom of oxygen there is an atom of copper. And for that reason we can give this substance a chemical name. We call it copper 2 oxide. In fact, from every single chemical name we can derive the composition of the substance. So this name here, copper 2 oxide, tells me exactly how many copper atoms there are for oxygen atoms. And just as we can give a compound a chemical name, we can also therefore give it a chemical formula. So the chemical formula for copper 2 oxide is CuO. That's 1 atom of copper for each atom of oxygen. Again, repeating, we cannot give salt water or brine a chemical formula because the salt doesn't occur in a fixed ratio. You cannot define how much salt there is in a glass of salt water. Now, at the beginning we looked at how we made mixtures and compounds. Now we're going to have a look at how we can separate them. And just as we could make a mixture by a physical process, we can also separate the components of a mixture by a physical process. So if we want to separate the salt from the water again, all we've got to do is take this glass and put it in a sunlit windowsill. Okay, so we leave it in the windowsill for a week, and what will happen is the water will slowly evaporate. Okay, evaporation is a physical process. So as the water evaporates, the salt will be left behind at the bottom of the glass jar. Now, if we want to get the water rather than the salt, then we have to use a process called distillation, which we'll look at and distillation, like evaporation, is a physical process. Now, in the case of the copper 2 oxide, if I want to get the copper back from the copper 2 oxide, then I'm going to use a chemical process again. To do this, what we're going to do is mix carbon powder with copper 2 oxide powder and then heat the mixture. Now the carbon powder and the copper oxide powder look virtually identical, so you can't really distinguish between the two in this mixture. However, what will happen as we heat this is that the carbon, which has a greater hunger for oxygen than the copper atoms, will grab the oxygen atoms from the copper and form carbon dioxide. And as they do that, copper will be left behind. Now this process is known as reduction. We say that the copper oxide is reduced by the carbon. In other words, oxygen from the copper 2 oxide is removed by the carbon atoms. So let's summarise this comparison. First of all, we can say that mixtures are made by physical processes. We remembered that the salt water is made simply by adding salt to water and stirring, whereas compounds are made by chemical processes. I had to heat the copper powder and make it react with oxygen in order to form the copper 2 oxide. Now the components of a mixture have no fixed ratio. We can say that they have a variable ratio. That's to say, you can add 1 teaspoon of salt to a glass of water, or 2 or 3 or 4, mix it up, stir it around, you've still got salt water. Whereas in a chemical compound, the components occur in a fixed ratio. When the oxygen combines with the copper atoms, they do so in a fixed and a regular way. For this reason, we can give a compound a chemical name and a chemical formula, but we cannot give a mixture a chemical name or formula, because the components have no definite ratio. They are variable. Now, as in the making of mixtures and compounds, well, they are separated in the same way. So we can separate the components of a mixture by a physical process. In this case, all we had to do was leave the jar of salt water in a window, in a sunlit window, and allow the water to evaporate, or to use distillation if we want to get hold of the water rather than the salt. Whereas in the case of a compound, we had to employ a chemical process again to separate the copper from the copper 2 oxide. And in this particular case, we used a method called reduction, and this involved mixing carbon powder with the copper 2 oxide and heating the mixture.